Well, here it is, the very end of the class. The very last thing we're doing is the analysis of variance. And if you're already given the lists of data, ANOVA is very easy to do. The challenging thing is when you need to separate the data yourself. For that, I'm going to use this, which comes from the Chapter 7 and 8 review, comparing high school GPAs and college GPAs. But first, I need to read the directions. So divide them by high school GPA. Those that have under a 3.25, here's where highlighters or different pens, different color pens is useful. Those whose GPA is between 3.26 and 3.7, and then in green is going to be those people that are over a 3.7. All right. So again, look at their high school GPA, and if it's under a 3.25, they're going to be purple. So under a 3.25, make sure I got purple. Yeah, that's purple. So under a 3.25, so that would be this person, so that one. And again, I highlight across, and if I had a highlighter, I would go all the way across, but I could just do it like this. Basically, it's connecting that 3.22 to a 3.1, but it's identifying them as being in this group. So next, if it's under 3.25 for their high school GPA, here's one, under 3.25, and another one right here, and under 3.25, and then under 3.25, and under 3.25. Okay, then I'm just going to quickly look through and double check, did I get all of the ones that are under a 3.25? And it looks like I did. All right, so the purple ones are done. Next, for the red ones. Sorry, I didn't realize I was off the screen. Okay, so for the red ones. So that's from 3.26 to 3.7. So one way I could think about it is basically up to and including 3.7. Not over 3.7, but up to a 3.7. And then I just ignore the purple ones because they've already been highlighted. So up to a 3.7, so below a 3.7, below a 3. Here's one. Below a 3.7, and below a 3.7, and there's one, another one, and another one, and then one more. All right, now, oh, just for completion, I feel like I should check this off. All right, those people are checked off. Now for the green people. So this is for the overachievers that got over a 3.7. So they're going to be green. Their high school GPA is over 3.7 and over 3.7, and the show off with the 4.1, and over 3.7, over 3.7, over 3.7, and then this one, and this one. There we go. Now, if you look down the list, everybody has been assigned a color, so nobody got left out. All right. Now what I need to do is type those into the calculator. So this is going to be list 1, and then this is going to be list 2, and then this is going to be list 3. So list 1 is all the purple people. But notice that I ask you about their college GPA. So when I go through and I'm looking at the purple people, it's actually their college GPA that I need to type in. So for all the purple people, I need to type in their college GPAs. And you don't really need to put a little dot by it like you do with the contingency table. Now for this part, I was thinking that I would just like pause the camera and then come back. But you could just put fast forward as I type these in. Or if you want to make sure that I do it right, then you should watch. So 3.1, 2.72. Let me double check. Right now we're doing the purple people. Okay. The purple people, but their college GPA. Purple. The next purples are down here. So 2.32, 2.65. And then we have two more purple people down here, 2.75 and 2.6. So my calculator says that's 8 people. So 8 that are purple. 1, 2, 3, 4, 5, 6, 7, 8. All right, so I think I did that part right. Now, these are the purple people, so I need to find the one variable statistics right there. So calculate the one variable statistics for list 1. All right, so there are 8 people here. They have an average of 2.711 in college with a standard deviation. S equals a 0.229. Okay, now it's time to move over to the red people and put them in list 2. And make sure you use a new list. So when we do the ANOVA, we're going to need the numbers right here, right here, and right here. So don't just type over L1, but actually start a new L2. And these are the red people that go in list 2. So the first one is their college GPA is 3.51, and then 3.33, and 3.32, 3.53, at 3.22, 3.42, 2.94, and 3.56. Oh, I didn't hit enter. Hold on. Okay, so there was a 2.94. Hit enter, Greg. Good job. Hit enter again. So it happens to be that it's 8 people for that. And I need to find the mean and standard deviation again. This time for list 2. And so this has 8 people. And their average is definitely better. 3.354, and the S is a 0.205. Since I know that there's 25 people total, this makes 16 people. 16 to 25 means that this should be 9 people. So if I did it right, that should end up to be a 9. Okay, so in list 3 goes the green people, but it has to be their college GPA. So move over to list 3, and now the first green one is 3.68, and then 3.61, and a 4.0, 3.89, and then a 3.81, 3.95, 3.57, a 4.0, and the last green one is 3.55. And sure enough, that's one more person. So this group has 9 people. And one more time, find the one variable statistics, this time for list 3. And the average is even better. Now it's up to a 3.784, and the standard deviation is a 0.185. Okay, so the claim is that the mean for group number 1, so you could just call this group number 1 and group number 2 and group number 3, equals the average for group number 2 equals the average for group number 3. That's what AVOVA does. It tests the claim that 3 or more means are the same. So on the calculator, you can just go to Stat, move over to Tests, and then it's near the bottom of the list. So you could either scroll through the whole thing, or you could just go to the top and then go up, and it's actually the last one on the list. So you do the AVOVA, it puts it on the screen, and it's waiting to know where are the lists. L1, comma, L2, comma, L3. And it won't do it if you don't put the commas, so make sure you put the commas. So the test statistic is F. Let me write that down over here. So F, capital F, equals a 57.798. The other information I need is this is degrees of freedom number 1, and this is degrees of freedom number 2. So I also need degrees of freedom number 1 was a 2, and degrees of freedom 2 was a 22. And then the F distribution looks like the chi-square distribution. It starts at 0. And then the critical value, I'll look up in just a moment. That's table A5. And this is going to be 95% confidence, so this is 0.05. And now for table A5. So on Canvas, I believe I have 2 versions of this. This is the original version that I got off of Google. And then I couldn't find this one anymore, so I found a different one. It's the same numbers, it just looks a little bit different, but it works the same. First, you have to make sure that it looks like this, 0.05 for the right, so it matches this. And then degrees of freedom number 1 is you look across the top, degrees of freedom 1 is a 2. And then degrees of freedom 2, so you look down the side and find 22, or the closest that they have. So they actually have a 22, and then go out for this row, and go down for this column, and then it's 3.44, 34. 3.44, 34. All right, all we need is the conclusion. Does a 57 go past a 3.4? Yes. Way past. That means reject the claim. So that means that the 3 means are not equal. As you could see, so even though this was only 8, and 9 people, in general, that's enough evidence to prove these are the people that didn't do so well in high school, and as you compare how they do in college, yeah, they got 3rd place. These are the people that were medium, which actually that's pretty good, but anyway, they were medium in high school, and they turned out to be, well, better than them, but not quite as good as them. And then these are the people that did well in high school, they're doing well in college as well. And again, that does not apply to every individual, but that is in general. All right, have a great day.